Hello students, welcome to the course Digital Signal Processing. We are discussing the unit number 2, that is Z transform, and the topic for today's discussion is inverse Z transform, that is IZT. So let's discuss one of the numerical. So in this numerical it is asked determine the partial fraction expansion of the proper function. So when we say it is the proper function, it means that the numerator and its degree will be in the picture for this comparison. So for this particular x of z, the numerator will have the degree 0 and the denominator will have the degree 2. So obviously 0 is less than 2, so that is why it is called as a proper function. So let's discuss this in detail for solving the value with respect to the partial fraction. So here the simple concept is used. Whatever the value we are having at the denominator, that is the degree, so it is nothing but the value of n, which we have seen in the earlier case. So capital N is equal to 2. So multiply and divide the denominator as well as the numerator by z square. So that is what done over here. So when we multiply the numerator as well as the denominator by the degree 2, we will get the value which is nothing but x of z is equal to z square by z square minus 1.5z plus 0.5. So this is further solved with respect to the partial fraction. So poles here will be just solved by the denominator with the quadratic equation format, so that is z square minus 1.5z plus 0.5. So if we solve this, it will give the fractions or the factors like z minus 1 and z minus 0.5. So these are the two factors which we got. Now just split this entire term into the format of a1 by z minus 1 plus a2 by z minus 0.5. So that is what done over here. So once we splitted it, then this particular term is nothing but the partial fraction for x of z by z. So if it is x of z by z, this is nothing but the simplified value. So for this, let's have the cross multiplication for these two terms. So z minus 0.5 into a1, so that is what done here, plus z minus 1 into a2. So that will be equated with the numerator term of x of z by z, that is z. So once we equate it to z, after putting the value of z equal to 1, that is over here, so obviously we will get only the value of a1. So this a2 will be cancelled. So value of a1 after solving this and by putting the value of z equal to 1, it will be a1 equal to 2. So once we got a1 equal to 2, just put it in the equation for z equal to 0.5. So once z equal to 0.5 means this second case, this will be gone and we will get the term in this particular format, that is 0.5 is equal to 0.5 minus 1 into a2. So by putting the values of a1 as well as a2 in the equation, which is just simplified over here, that is here, so a1 is 2 and a2 is nothing but minus 1. So this is what the x of z by z, which we got with the help of the partial fraction expansion. Now this can be simplified in the other way also. So for using the partial fraction, one may use the statement like a1 is equal to, let's say I want to find out the value of a1, then a1 is equal to z minus 1 into x of z by z at, let's say it is z equal to 1. So if this is done, then x of z by z is nothing but this value. So if I multiply this with the z minus 1, then obviously this z minus 1 and this z minus 1 will be cancelled, and that is to add z equal to 1. So if it is at the z equal to 1, so by putting it, it will be accepted like 1 upon 1 minus 0.5. So 1 upon 0.5 means it is nothing but the a1 equal to 2. So this is the alternate way to solve the values for a1 and a2, and this is nothing but the partial fraction expansion. Let's see the next example where we will concentrate for getting the x of n. So let's say this is what one of the example where we are being asked to find out the inverse z transform of x of z which is given by the equation 1 upon 1 minus 1 point z inverse plus 0.5 z raised to minus 2. This is already we solved in the earlier lecture, where we got the z transform for this one as a x of z is equal to 2 by 1 minus z inverse minus 1 upon 1 minus 0.5 z inverse. So if we got this particular x of z, what could be the probable x of n for three conditions? So these are the three probable x of n, but the x of n can be determined based on the ROC, that is region of convergence. So in the first example it is mentioned that ROC is mod z greater than 1. So if it is mod z greater than 1, let's say this is what the case we discuss. So here the case when the ROC is mod z greater than 1, it is obviously the causal. So if it is causal, then what is happening for the causal system, a raised to n un u of n, that is what the we can say the x of n. So just by comparing it with the given equation, so x of n from this x of z, it will be inverse z transform. So 2 will be constant, so it will be taken outside. So 2 into 1 raised to n. So how this 1 is coming? It is minus 1 into z raised to minus 1. So this is nothing but the term which can be written like z by z minus a, or one may write it like 1 upon 1 minus az inverse. So here value of a is 1. So 1 raised to n u of n. Why it is u of n? Because the system is causal. So the region of convergence is called over here, that is mod z greater than 1. So for mod z greater than 1, obviously it is a raised to n u of n. Similarly for this case, second case, a is nothing but 0.5. So again, for the circle with radius 0.5 and the circle with radius 1, obviously it is expected that we need to concentrate for this mod z greater than 1, means the condition over here, both the ROCs, means the ROC due to the circle with radius 0.5 and the circle with radius 1 should have the common ROC. So if the common ROC is to be existing, then it must be for the condition mod z greater than 1. So for this to happen, this must be 0.5 raised to n u of n. So by solving it further, 2 minus 0.5 raised to n u of n, that is nothing but the final value of x of n. Now further, if someone want to go for, let's say, the mod z less than 1, so if this is what the case, mod z less than 1, less than 0.5, sorry, mod z less than 0.5, that is case number B. So here the sequence is anti-causal. It means, let's say this is what one of the circle with 0.5 radius, this is another circle with radius 1. So everything is concentrated less than 0.5. So obviously this outer circle must be concentrated for less than 1. So in order to happen this entire thing, so as to get the common region of convergence as a less than 0.5, this is what we need to do. So here the simple thing is, again, a raised to n, that will be common. So in order to have the a raised to n, since it is nothing but minus a raised to n u of minus n minus 1, will have the ROC, that is nothing but z by z minus a. So this is what the reason why it is been referred as u of minus n minus 1, since it is the left sided sequence. So everything, or rather resultant ROC, will be inside the circle with radius 0.5. So that is why we need to concentrate for only this u of minus n minus 1, and this minus sign is due to the term minus a raised to n. So that is what the reason, and this minus minus plus will be there. So that is why this sign is changed to plus 0.5 raised to n. Now let's concentrate for the other things, like the when the ROC is in between 0.5 and 1. So it means that, let's say this is what the one of the circle with radius 0.5 and the other circle is radius 1. So now when we say this is what the ROC in between the two circles, if this is to happen, then obviously the circle which is having the radius 0.5, the ROC must be outside to that circle, and the circle with radius, let's say 1, the ROC must be inside to that circle. So the common region over here is nothing but this particular ROC. So that is nothing but the ring. So in order to happen the ring, so we need to go with the term like this is nothing but the first case when A is 1. So circle with radius 1. This is what the outer circle with radius 1, and the inner circle will be with the radius 0.5. So in order to happen this particular thing, we need to just proceed with the slight variation. So this variation will be minus 2 1 raised to n u of minus n minus 1, and the second case will be minus 0.5 raised to n u of n. So this will be the causal case and this will be the anti-causal case. Then only this third case will be happening. So this is about how to correlate the things with respect to the concept of finding the inverse Z transform as well as with respect to the concept of finding the ROCs. So the same thing is been discussed for this next problem. In this particular problem, h of z is given to us. So simplifying the h of z, so in order to have the stable system, the poles for this system after simplification will be nothing but the 1 by 2 and this is nothing but the 3. So in order to have the stable system, just try to recall the concept that the poles must be, or the ROC must include the unit circle. So in order to have the inclusion of unit circle, the ROC is to be taken as 1 by 2 less than mod z less than 3. So in order to happen this one, mod z greater than 1 by 2 means 1 by 2 raised to n u of n. Mod z less than 3 means 3 raised to n u of minus n minus 1. Second case, system is causal means ROC mod z greater than 3. So everything will be outside the circle. So it will be 1 by 2 raised to n u of n and plus 2 into 3 raised to n u of n. So that is been obtained from this particular expression. And the last case is nothing but the if the system is anti-causal means for this mod z less than 0.5. So for this case to happen, everything should be concentrated inside the circle with radius 0.5. So this is 1 by 2 raised to n plus this is nothing but 2 into 3 raised to n, and this is what the important point, that is u of minus n minus 1. So here we can conclude that the system is unstable. This is also unstable since it is not giving the appropriate ROC for the system. So this is all about the inverse Z transform and the related ROCs. So thank you everyone. Thank you very much.